Hi, good morning. Myself, I'm Dr. Arun Kumar, Associate Professor, Department of Mathematics, Savidya Institute of Technology. So, in this video, let us discuss some basic concepts of vector differentiation. Those are how to find gradient of a scalar field, divergence, and curl of a vector quantities. So, straight away, I'll start with the definition of a gradient. So, the gradient of a scalar, suppose phi is a scalar function, the gradient of that is denoted by grad phi or del phi like this. So it is defined as dou phi by dou x I plus dou phi by dou y j hat plus dou phi by dou z k hat. So if we differentiate the scalar function partially with respect to x, y, and z, and if we substitute in this, we're going to get what is the gradient of that scalar. So the next is the divergence of a vector field. So suppose if you have a vector f equals f1i plus f2j plus f3k, then the divergence of this vector is calculated like this, div f or del dot f. It is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. So I mean, you have to differentiate f1 I component partially with respect to x, j component f2 with respect to y partially, and k component that is f3 partially with respect to z, and if you substitute in this, we're going to get what is the divergence. And regarding curl of a vector, so it is defined like this: curl f or del cross f is determinant of ijk, dou by dou x, dou by dou y, dou by dou z, f1, f2, f3. If you expand this determinant, which includes the partial derivative, you're going to get what is the curl of a vector. So these are the three basic quantities of vector differentiation, very important. So gradient, divergence, and curl. And if a divergence is 0, it is called solenoidal, and curl of a vector is 0 is called irrotational. So this I'm going to discuss in the next video. So in this video is restricted only discussion about how to calculate the gradient, how to calculate the divergence, how to find out the curl of a given vectors, etc. So I'll just find out gradient, divergence, curl of some problems here. I'll start with the first one. Find the grad phi of x cube plus y cube plus z cube minus 3xy at 1, 1, 1. So the scalar was given. So we have to find what is the gradient of this scalar. So I'll just find out the gradient of this. So let us take the given function as phi, the scalar as phi, that is phi equals x cube plus y cube plus z cube minus 3xy. So we know that the grad phi, or in symbolic form, I can say del phi. The formula is it is dou phi by dou x I cap plus dou phi by dou y j plus dou phi by dou z to k cap. So this implies grad phi equals now. So according to this formula, we know we have to differentiate this phi partially with respect to x first, multiply with that with I, then partially with respect to y, multiply with j, then partially with respect to z and multiply with k and add it. So we're going to get what is the gradient. And remember, gradient of the scalar becomes vector. Now let us differentiate now with respect to x. So differentiation of x cube, it is 3x square first term, and here there is no x, so it is 0. Here there is no x, 0, and here it is minus 3y constant. Differentiation of x is 1 here, so therefore we get minus 3y. So if I differentiate that phi, the given function, with respect to x partially, we get 3x square minus 3y into I cap. So this is the first term of a gradient. Now coming to the second term, dou phi by dou y means you have to differentiate this phi partially with respect to y, and the resultant one you need to multiply by j hat. So with respect to y means here there is no y term, so the differentiation of this is 0. But here the differentiation of y cube was 3y square, so it is plus 3y square, and this term does not contain y, so it is 0. And coming to the last term, it is minus 3x into differentiation of y is 1 once again, so it is minus 3x into j cap. plus. So this is the second term. Now K, dou phi by dou z with respect to z. See here, there is no z here, here also no z, and last term also does not contain z. So there is only one term containing z, that is z cube. If I differentiate this term with respect to z partially, we know we get 3z square. So it is 3z square into k cap. So this is the third term. This is our grad. So this is how we can find the gradient of a scalar. Just differentiate that scalar partially with respect to x, y, z and multiply them with I, j, k and add. But in this problem, I need to calculate the grad phi at some particular point, 1, 1, 1. So I'll write at 1, 1, 1. The grad phi value is, so let us put x is 1, y is 1 here. See, x is 1, y is 1 means this is 3 and here minus 3 minus 0. So it is 0 into I cap plus here if I put, so this is 0 here also 1 square 1, 3 into 1, 3 minus here also 3 minus 0. So it is 0 j cap, 0 into j cap plus coming to the last term, if I put z is equal to 1 here, so 1 square is 1, 1 into 3, 3. So it is 3k cap. So I can say that the answer of this problem is just 3k cap. This is the gradient of a scalar. So this is how we can find the gradient of a given scalar function. So similarly, we can find out divergence curl of a vectors now. I'll go to the next problem. Next one, I'm going to take it like this. Find curl of curl A given vector A equals, it is xy I cap plus y square z j cap plus z square y k cap. So this is the problem here. But in this problem, the vector is given. I ask you to find what is the curl of this vector, and again curl of curl. Whatever curl will come, again for that you have to find curl. So 2 times curl you have to calculate. But anyway, in this problem, first I show you how to find curl, and again we'll repeat the same thing. So this is an example in which you're going to learn how to find the curl of a vector. So I'll just go to the next page. So first let us write the given vector solution. So given, so the given vector is vector A equals, it is xy I cap plus y square z j cap plus z square y k cap. So we know that the curl of a vector is defined as, it is I cap, j cap here, k cap, dou by dou x, dou by dou y, dou by dou z. This is f1, f2, f3. So where this f1 stands for high component, f2 stands for j component, and f3 stands for k component. So I mean x1 is xy, f2 is y square z, and f3 is z square y. So let us substitute. This is equal to determinant of I, j, k. This is dou by dou x, dou by dou y, dou by dou z. F1, you know it is xy, f2 is y square z, and f3 is z square y. So let us expand this determinant. This I cap into, so just leave this column, leave this row. It is a cross product of these two. Dou by dou y of this minus dou by dou y of this. I mean like this. So it is dou by dou y of z square y minus dou by dou z of y square z, the first term, minus j hat into, so just leave this column, leave this row. It is a cross product of this, dou by dou x of this, dou by dou x of z square into y minus dou by dou z of cross product this into this xy. It is just an expansion of a determinant plus k cap into, So leave this column, leave this row. So take a cross product now. Dou by dou x of this, dou by dou y of this. So it is dou by dou x of y square into z minus dou by dou y of xy. Right? So this is the expansion of a determinant. Now let us find the partial derivatives and simplify this. We get this is equal to I cap into, see first dou by dou y of this. So dou by dou y of this means z square is constant, differentiation of y is 1. So you get simply z square. Then minus dou by dou z of this, differentiation of z is 1. So y square into z is 1. So it is y square, z square minus y square. Then minus j cap into, now here dou by dou x of this, there is no x term here. So differentiation of this is 0. And dou by dou z of this, there is no z term here. So differentiation of this is also 0. So there is no term in j. And coming to the last term, k cap into, first dou by dou x of this, here also there is no x term. So the partial derivative of this is 0 because it is a constant, there is no x. And coming to this dou by dou y of this means differentiation of y is 1 into this x, so it is x with minus, so it is minus x. Right, so this implies curl A equals, so I'll write like this, z square minus y square into I cap minus 0 into j cap minus x into k cap. This is the curl. So this is how we can find the curl of a vector. So the previous problem I discussed how to find the divergence, gradient, and this is with respect to curl calculation. But in this problem, there is one more thing to find. That is, this is how we can find the curl. They ask find curl of curl, means whatever curl you are going to get here. For that, once again you have to calculate the curl. Means you have to take this as a fresh vector, new vector. So this is f1 now. This is f2 now. This is f3. So take the same formula and substitute. So now curl of curl A equals, again it is determinant of I cap, j cap, k cap. Here it is dou by dou x, dou by dou y, dou by dou z. And here f1 now it is z square minus y square. This one, this is f1. And f2, you know, it is minus 0. So I can write simply 0 here. And f3 is nothing but this minus x. Right. So this is f1, f2, f3 substituted. Now we expand this, we get curl of this. So this implies this is equal to, it is I cap into. So now leave this column, leave this row, product of these two. So it is dou by dou y of minus x, dou by dou y of minus x, minus, it is 0 anyway, because dou by dou z into 0. Now next minus j cap into, leave this column, leave this row. It is dou by dou x of minus x, dou by dou x of minus x, then minus cross product of this, dou by dou z of z square minus y square. Z square minus y square here. And the last term, it is k cap into, leave this column, leave this row. It is a product of these two. So we are 0 into this one, it becomes 0, minus, it is dou by dou y of this. It is dou by dou y of z square minus y square. So this is the expansion of a determinant. So now if you find out the partial derivatives and simplify, we're going to get what is the curl of this. So this is equal to now I cap into, so dou by dou x of this, nothing will come, differentiation of x, this is with respect to y, so nothing will come, it is 0, minus j cap into, so with respect to x means differentiation of x is 1, so it is minus 1 here, minus 1, And dou by dou z of this means differentiation of z square was 2z. And this term was 0. So it is minus 2z. Minus 2z. And coming to the last term, this with respect to y means this term is 0. Y square is 2y with minus. So it is minus 2y. Minus into this minus, it is plus 2y. So it is plus k cap into 2y. So therefore, we get curl of curl A is nothing but, there is no item. So I can take minus common and I can multiply with this. It is 1 plus 2z now. 1 plus 2z into j hat plus 2y into k hat. So this is the required answer for this problem. This is how we can find curl of curl A for this. So this is the procedure of finding the curl of a given vector. Now in the same way we can find the divergence also. So let us discuss how to find the divergence of a vector now. So now we shall start the third problem on finding divergence and curl of a vector. So find div f and curl f if vector f equals grad of x cube plus y cube plus z cube minus 3xy. So in this problem, the vector f is given like this. Given vector f equals, it is gradient of x cube plus y cube plus z cube minus 3xyz. Means if we calculate the gradient of this scalar function, that will become our vector. So even though it is a problem, ask you to find div and curl, indirectly the gradient also you have to calculate. So this is a problem in which you are going to calculate all the three quantities: gradient, divergence, and curl. So first let me calculate grad of this. To find out the grad of this one, I'll take this as phi, a scalar function. So let phi is equal to x cube plus y cube plus z cube minus 3xyz. So then grad phi, we know that grad phi is nothing but it is a dou phi by dou x I cap plus dou phi by dou y j cap plus dou phi by dou z k cap. Means you have to differentiate this phi scalar function partially with respect to x, then y, then with respect to z, and multiply with ijk and add. So let us do that first. So this is equal to, see first, if I differentiate partially with respect to x, the first term is x cube, and we know that the differentiation of x cube is 3x square. So 3x square, and here there is no x, here there is no x. So it is 3x square, and here there is x, and differentiation of x is 1 into this constant 3yz. So it is minus 3yz. So this is our dou phi by dou x, so this is into I cap. Plus dou phi by dou y means you have to differentiate with respect to y. So differentiation of y cube is, it is 3y square minus, with respect to y means here 3x into z is constant. So it is 3xz into differentiation of y is 1. So it is 3xz into j plus the last term with respect to z now, dou phi by dou z. So differentiation of z cube, it is 3z square minus this term 0, this term 0. Here 3xy into differentiation of z is 1. So it is minus 3xy into k cap. So just like a first problem, we have calculated the gradient of the scalar function. So you get grad phi. And you know grad of this is nothing but vector f. So I can take this grad phi as f here. So therefore I can write vector f is nothing but grad phi. So which is equal to, it is 3x square minus 3yz into I cap plus 3y square minus 3xz into j cap plus 3z square minus 3xy into k cap. So this is our vector f now. So whatever vector f is given, gradient of this You have simplified, we get this. So this is the vector field now, vector F, where this one represents F1. I'll write in a different color and show. So this one represents F1. This is nothing but F2, and this is nothing but F3. F1i plus F2j plus F3k. So this is a vector. For this vector, I have to find what is div of this and curl of this. So if you observe closely, we have calculated grad. Now I'm going to find div and curl. So it is a problem related to all the three quantities, div, curl, grad, and all. So let us calculate the first one, the div f. So div f, you know the formula of div f. It is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. Now this is equal to dou f means I'll write again like this, dou by dou x of f1. So it is f1 is 3x square minus 3yz plus dou by dou y of f2. And you know f2 already mentioned here. It is 3y square minus 3xz plus dou by dou z of f3. F3 is, it is 3z square minus 3xy. So if you just find the partial derivative of this, you're going to get what is the divergence of this vector. So this implies div f equals now dou by dou x of this. So differentiation of x square is 2x, 2 into 3, it is 6x, and here there is no x term, it is 0. So this is the partial derivative of first term, 6x plus 0, so you get 6x. Plus similarly, next term, dou by dou y of this. You know y square is 2y, 2 into 3, 6y. And here there is no y term, so it is 0. So it is 6x plus 6y plus differentiation of z square is 2z. So 2 into 3 it is 6z, and here there is no z term, is 0 plus 6z. So this is the divergence of this vector. Div f is 6x plus 6y plus 6z. So this is how we can calculate the divergence of a vector. Now, the second thing is we need to find what is the curl f. And we know that the formula for curl f is determinant of I, j, k, dou by dou x, dou by dou y, dou by dou z. Here f1, f2, f3. So here let us substitute this value of f1, f2, f3 in this determinant and expand. We'll get what is curl f. So this is equal to determinant of, I'll write here, I cap into I cap dou by dou x of f1. So we know f1 is, it is 3x square minus 3yz. Now j cap dou by dou y of f2. F2 is, it is 3y square minus 3xz, and k cap dou by dou z of f3, it is 3z square minus 3xy. Right, f1, f2, f3 are substituted. So let us expand this determinant. It is I cap into. Straight away I'll expand. So I'm not going to write and show. So this, leave this column, leave this row. It is a cross product of these. It is dou by dou y of this. See, dou by dou y of, or we'll write once again. What is that? Dou by dou y of, it is 3z square minus 3xy minus dou by dou z of, it is 3y square minus 3xz. So first term minus j cap into, so leave this column, leave this row. It is dou by dou x of this. It is dou by dou x of 3z square minus 3xy, then minus, it is dou by dou z of, it is 3x square minus 3y. So this is the j term plus k cap into, k term is, leave this column, leave this row. It is dou by dou x of this. It is dou by dou x of 3y square minus 3xz minus, it is dou by dou y of 3x square minus 3yz. So this is the k component here. So the determinant was expanded. Now let us find the partial derivative of each of this, and we simplify. We get what is the curl of this vector. Now let us find the partial derivatives of this. Now we'll find the partial derivatives of this, so that we'll get curl f. So this implies curl F equals, sorry, next page, sorry, curl F equals the first I component into, see this, it is dou by dou I of this. So this term was 0. So it is 3x into differentiation of y is 1 minus 3x. And here with respect to z means 3x into z is 1 minus 3x, minus into minus plus. So it is minus 3x plus 3x. The next term is minus 3x plus 3x minus j cap into this is dou by dou x of this is minus 3y here, then minus with respect to z is minus 3y, minus into minus plus 3y. So it is minus 3y plus 3y again, minus 3y plus 3y, then plus k cap into with respect to z x now here, this is minus 3z, and with respect to y means minus of minus plus 3z, minus 3z plus 3z, minus 3z plus 3z. So now if you observe, all these terms gets cancelled. So the value of this is 0. So curl F is 0 here. So this is how we can calculate the curl of a vector. So this is the problem in which all the three coefficients are calculated: the gradient, divergence, and curl. So similar to the last problem we did. So in the same way, I'm going to solve one more problem. So same type. Let us find curl, dive, etc. The fourth problem. The fourth one is find dive F and curl F if vector F equals, it is gradient of x y cube z square, x y cube z square here. So it is very much similar to the last one. So here the given function is vector F equals grad of x y cube z square. So this is a scalar function. So I'll take the scalar function as phi. So let phi equals, it is x y cube z square. Now let us find the gradient of this. Now grad phi is nothing but it is dou phi by dou x I cap plus dou phi by dou y j cap plus dou phi by dou y dou z k cap. So let us calculate this right away. So this with respect to x, if I differentiate, so here y cube z square constant, differentiation of x is 1. So it is, the first term is y cube z square. Now dou phi by dou y means it is 3x y square z square j cap. With respect to z means it is 2x y cube z k cap. Partial differentiation is this dou phi by dou x, dou phi by dou y here, dou phi by dou. So this is our grad phi. So therefore our f becomes, vector f is nothing but gradient of phi here, gradient of phi. So this is y cube z square I cap plus 3x y square z square j cap plus 2x y cube z k cap. So this is our vector f. Right. So once you get vector f, like a last problem, I can find dive and curl of this. The first thing is dive f. So dive f, we know dive f is dou f1 by dou x plus dou f2 by dou y plus dou f3 by dou z. So this is equal to. So as we know here, the f1 is the I coefficient. So this is our f1. So this is our f2 and this is our f3. So let us differentiate this f1 partially with respect to x, f2 partially with respect to y, and f3 partially with respect to z. We get what is divergence. So dou f1 by dou x means it is dou by dou x of f1 is y cube z square plus dou by dou y of f2. It is 3x y square z square plus dou by dou z of f3. F3 is, it is 2x y cube into z. So just find the partial derivatives. We get div f equals the first term. There is no x here, so it is a constant. So differentiation of a constant is 0. the first term becomes 0 plus the second term. This is with respect to y, and differentiation of y square is 2y. 2y into 3, it is 6xy z square plus the next term. This is with respect to z, so it is 2xy cube into z is 1. So this is the divergence of this vector. So this is how we can find the div f. Now similarly, the next thing is the curl f, and we know that the formula for curl f is this: I, j, k, dou by dou x, dou by dou y, dou by dou z, f1, f2, f3. Now let us substitute this f1, f2, f3 in this and expand the determinant. We get curl f. So this is I cap here, dou by dou x, f1. We know f1 is y cube z square. Next j cap dou by dou y here. f2 was, it is 3xy square. K cap into dou by dou z here. This is 2xy cube z. So f1, f2, f3 are substituted. Now we have to differentiate partially. So expand the determinant and differentiate partially. The first term, I cap it. Now I'll leave this term, leave this column. So dou by dou y of this. Straight away I'll do dou by dou y of this. Differentiation of y cube is 3y square. 3 into 2, 6y square xz. 6xy square z minus product of these two. Dou by dou z of this. And here there is no z term. So dou by dou z of this is 0. 0 minus j cap into, leave this column, leave this row. It is dou by dou x of this into this. So differentiation of x is 1. So it is 2 into y cube z. 2 into y cube z minus cross product of these two. Dou by dou z of this. So differentiation of z square is 2z. So it is 2z y cube. Or I can write 2y cube z. 2y cube z. Then plus k cap into the last. Dou by dou x of this. Differentiation of x is 1. So it is 3y square. 3y square. Then minus dou by dou y of this. So differentiation of y cube. Oh, sorry, I made a small mistake here. Y cube z. This is 3x y square z square is that. 3x square y square z is the 2x y cube z. Okay, I cap. This is dou by dou y of this one. It is correct. Dou by dou z of this. It becomes 2 into 2, 6x y square z. Sorry guys, this is, I just erased it. This term was, again, this is 6x y square z. 6x y square z, because I made a mistake here while writing the problem. So it becomes this j, anyway I'm leaving k. If I leave the dou by dou x of this one is 3y square z square. 3y square z square minus dou by dou y of this. Differentiation of y cube is 3y square. 3y square z square again. 3y square z square. Now it is correct. Now if you observe, all these terms gets cancelled. So the value of curl f is 0 for this problem also. Real. So this is how we can find the divergence and curl of a vector fields. So this is the procedure of calculating the basic vector quantities like the divergence, gradient, curl, and all other things. So like this, I'll just write 1 or 2 problems. So you can try after watching this video. So I'll just make it as problem number 5, problem number 6. It's just about calculation of gradient, divergence, and curl. So the 5th one is this: find div of grad phi. If phi equals, it is 2x cube y square z power 4. You can try this. Phi is given, you can find grad phi, and for that grad phi you can find the divergence. The 7th one is if vector f equals, it is x plus y plus 1 into I cap plus j cap minus of x plus y into k cap, then prove that vector f dot curl f equals 0. So you have to find the curl of this vector first. Curl f already we have discussed how to find. Then take a dot product of the curl f with this original vector f. So the dot product should be equal to 0. So overall, if you see, it is a problem on finding gradient, divergence, curl. That's all. Along with that, some conditions are given. You have to show that conditions are satisfied. So this is how we can find the divergence, curl gradient of scalars and vectors. Thank you.